Bismillahirrahmanirrahim. Work. Work done by a constant force. The work W done by a constant force on an object is defined as the product of the component of force along the direction of displacement and the magnitude of displacement. And the work done by a net force is given by the formula, which is the dot product of force and displacement. And what is the dot product? We know that dot product is calculated by FD cos of theta, magnitude of the first vector, magnitude of the second vector, and the cos of the angle between two vectors. Actually, when a person applies a force on a body at some angle theta, then a component of force is responsible for the movement, and the second component or the y component is lost and no work is being done by that y component of force if the object moves along x-axis. It means a part of the force is lost and the remaining part applies and it moves the body or it performs work. And by doing work, that part of the force stores energy in that body, and this energy which is stored is known as work, and this is calculated how much energy is stored in this body during this process of work. That is calculated by the formula FD cos of theta. In other words, we define the work W done by the force as a scalar product of the force and displacement, where x component of the force, magnitude of x component of the force, that is F cos of theta, is multiplied with the magnitude of displacement, and the result will be a value known as work, which is actually the energy stored in that body on which the force is applied and distance is displaced. The quantity F cos of theta is a component of force in the direction of displacement. Thus, the work done on a body by a constant force is defined as the product of the magnitude of the displacement and the component of the force in the direction of the displacement. The work is a scalar quantity as it has no direction, as energy has no direction. Work is a form of energy which is stored in the body, and energy has no direction. As it is stored in the body, it has no direction. The SI unit of work is Newton meter. The unit of force is Newton and the unit of distance is meter. So Newton meter is the unit of work, and it is named as joule. Joule is only the name of Newton dot meter. It is nothing but a name. Joule is a name of Newton dot meter. Can you tell how much work is being done in these two phenomena in figure 4.2a and 4.2b? In the first figure, you see that when a bucket is carried through, then the force is applied on body, is vertically force is applied and no horizontal component of the force is applied in the bucket. And the distance which is being displaced by the bucket is d. Both are perpendicular to each other. The force and the displacement are perpendicular to each other. So angle is a 90. So no component of force is actually doing work on that bucket. So total work done on the bucket is 0. It means that when the bucket is carried through to other point and by moving some distance, no energy is stored in that bucket. As no force is moving the object, or no force is applied on the bucket to move it horizontally. Just it is carried away and not the force is being applied to move it. So no energy is stored in the bucket. From initial point, it has the energy. It is, if it is at some height from the ground, it has some potential energy. And at the second point, it has the same energy. No energy is increased as no work has done because of the force. That force is not moving the object, that is just carrying the object. So when a force is applied on a body to move it and the body moves because of the push of the force, then work is performed and then that work is stored in the body as a form of energy. So in this case, when the bucket is pulled and carried away, then though no work is stored in the bucket and no work is performed, no work is done. Similarly, in the second figure, when the force is applied on a wall, that force doesn't move the wall away, so the displacement is zero. So F dot D will be equal to 0. It means that no energy is stored in the wall. Unless and until the body is displaced by the force, no work will be done. So in this case also, there is no work done. Work can be positive, negative, and zero. If the force is performing the displacement or force is causing the displacement, force is coercing the body to move, force is trying to move the body, force moves the body, then it means that work is performed, work is done by the force on the body and the energy will be increased, energy will be stored in the body. So some energy will be added and this type of work is known as positive work. But if a body is moving in the forward direction and some force tries to stop it by pulling it back, it means that angle will be greater than 90 between the x-axis and the force. In the first case, angle was less than 90 and cos of angle which is less than 90 is always positive. But the cos of angle which is greater than 90 is always negative. It is because that the force is actually stopping the body or decreasing the energy, so it is negative work. This negative work, when added to the energy of the body, the energy of the body decreases and it gets slows down. So the work done by this force, which is making an angle greater than 90, is always considered as negative work as it slows down the object. And when the force is applied to the body perpendicular to the direction of movement, it doesn't slows down or speeds up the body. So it means that angle is 90, cos of 90 is equal to 0. It means that it will not slows down or not speeds up the body. So it means that there is no work done performed by this force. So when the angle is 90, total work done will be equal to 0. So from the definition of work, we find that work is a scalar quantity. And if angle is less than 90, work is done and it is said to be positive work. That is, it increases the speed of the body or it increases the energy of the body, kinetic energy of the body. And if angle is 90, then no work is done. And if angle is greater than 90, then the work done is said to be negative and the force, as in this case, force tries to stop or slows down the object. So the work done by this force will be negative. Thank you students for watching the video. And please visit the website www.cadcollege.com for more information, and please subscribe our channel for informative lectures and videos.